Hello, everyone. My name is Treasure, a trainer here at Tech Here Academy, and we'll be talking about partitioning today. For our table of contents, we'll be talking about why partitioning, what is partitioning, why we use partitioning, the types, range partitioning, which is what we're going to be working on today, and then we'll just wrap up from there. So, for why partitioning? Imagine you have a sales table with millions of rows, like a large sales table spanning several years. So when you run queries that you need to that when you run queries that only need last year's data, for example, Oracle still scans everything. With this vast amount of data, backups can be slow, deletes can take a lot of time, and the performance of your database will drop as your table grows. So this is where partitioning comes in. It helps Oracle divide a large table into smaller logical chunks called partitions. I would explain later what logical chunks mean, but in simple terms, partitioning is like a massive warehouse. So just imagine like a massive warehouse in your mind right now, a warehouse of data, and it's organized into smaller, well-labeled sections so that Oracle can find things faster and manage them more easily. What is partitioning? Partitioning is a process of dividing a large table or index into smaller, more manageable pieces while still allowing them to be queried as a single logical object. So think of it like this. Let's say you're trying to organize your clothes in your wardrobe or your closet, and then you organize it into sections like your skirts, your trousers, or jackets into one wardrobe. You use everything, it's still inside the same wardrobe, but you just know exactly where to find it because they are now in some kind of partitions or some kind of sections, and you can find it easily. So Oracle still sees it as one table. That's why I said it's logical, but physically it's stored in segments per partition. This improves query performance, data management, and maintenance. We'll go on to why we use partitioning. When you're querying large data without partitioning, you would have to do full table. Oracle would have to do full table scans, but um, with partitioning scans only it scans only needed partitions. For data management, without partitioning, it's hard to delete or archive old data. But with partitioning, you could just drop old or archive old partitions instantly. For maintenance, without partitioning, is a longer downtime for reorganization of your database. But with partitioning, you can now handle those partitions independently. And then for storage, it's one big segment without partitioning. But with partitioning, each partition can now have its own table space. Types of partitioning. There's a range partitioning, list partitioning, hash partitioning, and composite partitioning. So range partitioning is based on a range of values like your dates or IDs. For example, orders from 2001, 2002, 2003 are in separate partitions. And range partitioning is most common when you're dealing with time-based data. For list partitioning, it's based on discrete values. So for example, yes, say you have discrete values like your country's column, you have USA, UK, Canada, you can now separate those values into partitions. For hash partitioning is based on a hash function. It distributes data evenly when no natural partition key exists. So if you don't use your range or list partition, Oracle would just distribute the data evenly, and it's good for balancing load. And then for composite partitioning, it's a combination of two, because it's composite. It can be range hash or range list. So for example, if you partition by year, you're using a range, and then you can now sub-partition by the region to make that a range list partition, for example. So I'll be using this table called Facts, Internet Sales, and Reach. Don't mind the name for now. Just try to follow what um explaining. So I'll select from this table just so we can see a preview of the table. Yeah, so this is a quick preview of the table. Let's count the rows in this table. It's about 60,000 rows, 60,398 rows. And this is a very nice sample data set we can use to work on partitioning. Now, if I select again, we can see that this showed a preview of 50 rows. That's how Oracle displays data. But if we keep scrolling down and keep scrolling and keep scrolling, we can see that the amount of seconds keep increasing as we keep going down, as more rows come up. But yeah, that's just a preview of this data. So for the partitioning part, I'm going to run a query without partitioning. It will be an aggregation query. So I'm using an aggregation function like sum. So let's say I want to select the sum for sales amounts. Let's just use sales amounts, for example. Sales amounts. From this table. And then I'm going to give my order date a range to be between 2003. Okay, by the way, we can see that the order dates here, if in ascending order, it has 2001 at the top. If we check how many years are here, we can see that this is also 2004. So it has a range of dates values from 2001 to 2004, just for us to keep that in mind. So let's say we want to work with 2003, January of 2003. Let me use the to date function so that we can just go along with to avoid data type problems. So dates, yeah, and December of 2003. This will be 12/31. Okay, still using my to date function. So I'm going to run this query. Oh, sorry, this should be 31 instead of 32. Let me run that again. Okay, so we have the sum of our sales amounts. I think this is 9 million and something thereabouts. So I will run the explain plan for this so we can see how the path Oracle takes to execute this query. Explain plan for, I'm copying the query and pasting, and then I'm going to, after it explains it, I want it to give me the display. So select from DBMS xplan dot display. Okay. Explained, and then I'm going to run the explain plan. Okay, great. So currently this table isn't partitioned. So every query, even for 2003, makes Oracle scans all 60,000 rows. Oracle reads all blocks, so it's a full table scan, and there's more I/O that is consumed. Notice here that it says table access full for the facts internet sales enriched table. This means that Oracle had to do a scan through every single row in that table, even though I was only interested in the row of 2003 or in the sales data of 2003. you'll notice that he estimated 19,632 rows, but that doesn't mean it ignored the rest. So it still scanned those 60,000 rows to find the 19,000 rows that, or 19,000 or so rows that matched what we're looking for. So it's like you're searching for 1 year's record inside a 4-year box, but you still open the whole box. That's what basically just did. I would copy this execution plan. I should be able to copy that and just paste under this so that when we're done, when we're done with the partitioning, we can now compare the two execution plans. So let us create our partition table. So I'm going to create another table. Create table. Let's limit fact internet sales parts, since this is going to be a partition table. Add some columns. Let me see what columns we want to add to this table. Okay, so we can go with our product key. Products key. You can go with customer key. I would still add the data types of the columns, but let's just define what we want first. Order dates, let's go with that since we're working with range partitioning. Sales amounts. What other one do we want to pick? I don't have to pick everything here. Okay, so we can go with sales order number and order quantity and unit price. So let's pick those three. So sales order number, order quantity. Hope that is spelled right. Order quantity, unit price. So let's give each column their, this can be number, customer key, it's a number, order date. I'll just use timestamp instead of dates because it allows me to see the timestamp and then seconds and all of that, as you can see here. Sales amount, this should also be number. Don't forget my comma so that Oracle doesn't throw an error. Sales order number. Okay, so this is a combination of text and number. So I'm going to use varchar or varchar, anyone. I can just give it a size of 20. And then for order quantity, I'm going to say number. And unit price number as well. Okay, cool. Now for the partitioning parts, so I'm going to partition by range. The column I'm partitioning on is the order date column. And then I'll list my partitions here. So partition, let's say P2001 for, since we have dates from 2001 to 2004. So we want to partition this dates column by each year. So partition values less than, let me write this in, type this in capital letters, less than dates from 2002. So all the dates that are less than 2002, January of 2002, all fall in 2001 from our table, right? So I'm going to do that. I would also use my to date function as well. So this should be YYYY MMDD. And then yeah, then comma. So I'm going to do this again for 2002, 2003, 4. So I'm going to change this to 2, 3, 4. And then change this to 3, 4, 5. Okay, cool. I'm also going to create a last partition for, let's say, since we don't know everything that is inside this data, anything that falls out of this bracket. So I just say pmax values less than the max value. Okay, and then, okay, hope this works. Okay, so I will create this table, fact table. Okay, so a table has been created. Perfect. I'm going to insert some values into this table. So insert into this table. Selecting. So I want to insert values from our old table into this new table we've just created. I'm just going to copy that so I don't take time. Just delete all of that since we're making inserts. Delete this. Yeah. Selecting from our old table. Okay. This is on our enriched table, the table we used before. Enriched. And then I'm just going to commit that so that we don't lose any data. Remind me, I just like writing keywords with caps lock. Okay, so insert this. So 60,000 rows have been inserted into this table and the commit has been complete. I'll select from the table, select star from this table. Yes, so the columns that we select, so you can see our columns in that table. So we're going to rerun the same query we ran before on our partition table now and check the explain plan for this table. Okay, we're going to change this to parts because it's our new table, our working one. We're going to change this also to parts. And let us try that, looking to see if I'll see any error. Okay, that's fine. It's fine. So obviously we're going to get the same thing because we just copied that table. But let's look at the explain plan now. Okay, great. So we created 4 partitions from 2001 to 2004. And then, so we can see that each partition stores rows that fall within its date range. That's how the partition would work. So Oracle no longer needs to scan the whole table. You can see that it says here the operation it's doing is now a partition range single. Unlike before, it didn't have an operation it was just doing a full scan. Yeah. And then you can see that under the P start stop colon, we have 3 here. This means that Oracle was smart enough to go directly into the 2003 partition only. That's our third partition in that sense, completely skipping other years. This is something that is called partition pruning. So it's one of is a big performance benefit of partition pruning. So Oracle automatically just prunes away partitions that don't match the where condition, scanning only the relevant ones that we're looking for. So instead of checking, if you are using your warehouse, the warehouse imagination I painted, the warehouse scenario I painted in your mind earlier. So instead of checking every shelf in the warehouse, Oracle just went straight to the one that is labeled 2003 and gave us what we want. So you can imagine how much faster queries become when your table has millions of rows. I mean, this is just 60,000 rows. When you're talking of data that spans up to gigabytes and even terabytes these days. So these performance gains are they are different, they are vast, right? So two columns I would like to, I think I already pointed your attention to it. You can see P start and P stop 3 here. If I run the same thing and change this partition to, let's say 2004, for example, the P start and P stop is supposed to change to the fourth partition. Yes. So it's now on the fourth partition. So that is how your partitioning works. Now you might notice something interesting. Also, before partitioning, I mentioned that we had a full table scan, right? So, but after partitioning, Oracle performed what I like to call a partition aware scan. So it's now aware of the partition. It just targets data we care about. Gave us 47,000 rows. These rows are in the fourth partition, the 2004 partition. It doesn't have to scan the 60,000 rows like it did before. It just goes to the fourth partition and gives us what we need. There's a predicate line here that says predicate information. If you notice, it shows the predicate line saying filter order dates by order dates less than or equal to the timestamp that we gave it. In the former one, let me go to the former one. It has a full range that it scans. You can see it here. It has a full range that it scans. This one, it just goes. You can see that it's a full range from the January to December. This one, it just goes straight to the 2004 and gives us everything that is inside the 2004 box in that way. So because of partitioning, the optimizer has now narrowed the scope. See where it says partition range single P start and P stop. That's now narrowed this code and opened only the 2004 partition, in this case, the fourth partition, and giving us what we need. The predicate here is just being shown as part of the plan, but the heavy lifting, which would have been done by the where condition, is now done by the partition that you have given it. So now the estimated cost might not look big. I wish I had a demo table that would give us like 1 billion rows. But when you scale that, you will see that partitioning scales far better as the data volume increases, because it minimizes the amount of data that Oracle has to now read and process. So yeah, that's a bit about partition, Oracle, the way Oracle partitions data, or range partitioning in this context, since we dwelt on range partitioning today. Some real world cases of partitioning in banking system. We can separate transactions by quarter or by year. In the e-commerce system, we can separate orders by month or year. In analytics, we can archive old partitions to cheaper storage. So older data that is not accessed frequently, say sales from, let's say we don't need the sales from 2001 and 2002. We can now move it out of the main expensive storage like your SSD or production disks and move it to a cheaper, slower storage. So partition is not just about speed, it's about manageability. When you're working with millions or billions of rows, it becomes very, very, very essential. Some key takeaways from here. Okay, I said partitioning device data for performance and manageability. Oracle automatically chooses partitions during query execution. Range partitioning is perfect for time-based data, and you can perform partition level maintenance operations instantly. Thank you very much for the session. I hope you gained one or two, and I would see you in the next one.